Okay, so let's move into a new topic. We have learned how to factor, and now we are going to use that knowledge in solving equations that are going to require us to factor in order to solve them. So before I get into that, I have a statement that I'd like to put up here. If A times B equals 0, then. It's the then part we need to know. Then what? Most people would say, well, B times A equals 0. And that's true. You can flip it around, and B times A does equal 0. But really the key is this. If you multiply two things together, two numbers together, shall I say, or even three numbers or four numbers or however many numbers together, and they equal 0, that means one of those numbers has to be what? It has to be 0. So then, either A equals 0 or B equals 0. So we're going to use that little statement to help us solve. So watch this a second. I'm being asked to solve, and I am given this multiplication problem, right? It is a multiplication problem, isn't it? I've got this parenthesis times this parenthesis, don't I? Okay, now before your brain goes too far off the deep end, shall I say, because most people see these two parentheses and their brain wants to multiply them together. And you know, in most cases that's true, but they're asking me to solve. And what they have given me is one parenthesis times a second parenthesis. And that multiplication problem is supposed to equal 0. Well, if I look up at this statement we made, if A times B equals 0, right? If I multiply these two things together and they equal 0, then either the first one equals 0 or the second one equals 0, right? Well, I'm taking this parenthesis and multiplying it by this parenthesis and they equal 0. That means one of those parentheses has to equal what? Yeah, one of those parentheses has got to be equal to 0. So, do I know which one? Right, it could be the first one, right? So we could have 2x minus 3 equals 0, couldn't we? But, right, here's the or it could be the second one equaling 0, couldn't it? Well, that gives me two nice little equations to go solve, doesn't it? All right, you know how to solve these. So we have 2x equals 3 and then x equals 3 over 2. Agreed? And then the second one, we would end up with x equaling -1, wouldn't we? Right? Okay. Easy peasy, yes? Now some of you are like, well, how do I know if this works? So you know what, let's check it. So I am going to check the first one of 3/2. So I would plug in 3 over 2 for my x. With me? Whoops. See, I put an x in there, and we're supposed to put 3 over 2 in there, so hang in there. Let me get rid of this. Okay, so then 3 over 2 plus 1 and equals 0. So let's figure out the first parenthesis. What's 2 times 3 over 2? Yeah, the 2's will drop, won't they? So that'll give me 3 minus 3. And I'm going to kind of leave this second parenthesis alone a second. And 3 minus 3 is what? Yeah, that's 0. So whatever number is in this second parenthesis, I really don't care. Because the first parenthesis went to 0, so I end up with 0 equals 0, don't I? Lovely. That's exactly what was supposed to happen. Okay, let's check the second number, x equaling -1. So if I plug that in to the original problem for my x, I have 2 times -1 minus the 3 in the first parenthesis. And in the second parenthesis, we have -1 plus 1. And that product equals 0, right? Okay, so in the first parenthesis, yeah, that's -2 minus 3. But the second parenthesis is 0, isn't it? Well now, the left side turns out to be 0. So 0 equals 0. With me? If I can get a problem, an equation that's not linear into a linear format, it's very easy to solve. You're like, what do you mean by that? Well, stay tuned for a couple more examples. So let's look at the second example. Notice, I have x times that parenthesis, correct? And this multiplication problem is supposed to equal 0, isn't it? So remember the statement we made before. If I have a, which you consider one number or one parenthesis, multiplied by b, which you could look at as a second number or a second parenthesis, if they equal 0 when I multiply them, that means one of them must be equal to 0. Agreed? Well, I have got x times this parenthesis, and it equals 0, which means what? Yeah, it means one of them has got to be 0. Either that x is 0, right? Or that parenthesis is 0, isn't it? Well now, this one's already solved. X is by itself. X equals 0 there. Got it? That second one though, I need to solve for it. So we have to move the 1 over, and then we've got to divide by 3, don't we? Which means we have a second answer of x equaling 1/3. Agreed? Okay. Makes sense? Good. Let's look at number 3. Now, number 3 says x squared plus 4x equals 0. Well, I don't know about you, but I don't know how to solve a second degree equation. If it was a first degree equation like this one, I know how to solve that. That's really easy. We move the 1 to the other side, we divide by 3, x is by itself. Yay! But this one, I don't know how to solve it because of that second degree equation. So, let's think about this. If we could take the second degree equation and reduce it, so to speak, break it down to first degree equations, then I could solve it, right? So, what process do we have that will take addition or subtraction problems and break them down into first degree equations? And will also make it into a multiplication problem. What is that? Yeah, some of you said it. Factoring. Doesn't factoring take addition and subtraction problems and make them into multiplication problems? And doesn't factoring also make them into linear parts? Right? Okay, so here's the deal. You have to remember the first step of factoring, which is, good, reduce. See if we can divide everything by the same number or variable, right? Okay, so in this case, do they have anything in common? Yes, they do. They have an x. So I am going to factor out an x. So when I factor out an x, what remains? X plus 4. Excellent. And this equals 0, doesn't it? By the way, equaling 0 here is a key. If it doesn't equal 0, I can't go to factoring. Wait, pause the video and go back and replay that because that's important for you to write down. Well, I'll say it again then. If this does not equal 0, you can't factor it. Got it? Why? Because the statement we made just a few minutes ago said if A times B equals what? Equals 0. It has to equal 0 before you can factor it. Got it? Okay, so now, doesn't this line look like this one over here in number 2? Sure, which means I'm going to take this first number or parenthesis or variable, whatever you want to call it, and I'm going to set it equal to 0, and it was being multiplied by the parenthesis of x plus 4, and I'm going to make that equal 0. And by the way, no, I don't need this parenthesis here, so let me just erase it. And again, this one's already solved, isn't it? This one? Yeah, all I have to do is move the 4 to the other side, and now the x is by itself. With me? Okay, something I'd like you to notice. This particular equation, the power was 2, wasn't it? That tells me I'm supposed to have 2 answers for x. Do I have 2 answers for x? I sure do. So check. Okay, stay tuned. Got a couple more examples. All right, let's look at this fourth problem. So I have x squared plus 3x minus 10 equals 0, correct? Again, I don't know how to solve a second degree equation. But if it was a first degree equation, that would be easier to solve, wouldn't it? So question, how do you take a second degree equation and break it down to a first degree equation? Good, you factor. But remember what I said just a few moments ago. You can only factor if it is equal to what? 0. Is it equal to 0? Yes, it is. Which means I can utilize that if a times b equals 0, then a is 0 or b is 0. That's the whole reason I need it equal to 0. Got it? Okay, so let's go through the factoring process. So first factor. And you are factoring the x squared plus 3x minus 10. And question is, can you reduce it? Nope. So now, right, you remember? You've got to break this you got to take these 3 terms and make it to 4 terms, don't you? Remember what we discussed before in a previous lecture? Good, you're going to have to take the first number, which is 1, multiply it by that last number, which is negative 10, and that equals negative 10, doesn't it? And then you got to find all the combinations that multiply to negative 10, and you're hoping one of them will add to a positive 3. Do we have one of those? Yes, we do. This combination here will multiply to a negative 10 as well as add to a positive 3. Agreed? Okay, so now I have x squared minus 2x plus 5x minus 10. And now that I have 4 terms, what do? Good. We're going to pair them up or group them. That's another word we can use. And I'm going to ask the same question all over again, right? What do they have in common? What can I reduce each of these pairs by? So the first pair, what can you reduce by? Good. You can reduce by x. So I'm going to take out that x, and what remains is x minus 2. Correct? The second pair, what can you reduce by? Good. It has to be a positive number because the first term is positive, and it's a 5. So you're going to factor out or divide out. Same thing, a positive 5. What remains? Good. X minus 2. And then you see, right, that the x plus 5 had been distributed to the x minus 2. Cool? And now you know that this second degree equation, now that we factored it, we know that this must equal 0. So here is the problem I'm actually solving. Got it? Okay, so that means the first parenthesis is equal to 0 or the second parenthesis is equal to 0, correct? So that means your x must be equal to a negative 5 or your x could be equal to a positive 2, right? Okay, now by the way, let me stop us a second. In the original problem, the power was 2, wasn't it? The degree was 2, wasn't it? Which means I should have come up with how many answers for x? 2. Did I come up with 2 answers for x? I sure did. With me? Okay. Let's look at problem number 5. Now I've got a third power. I was like, oh my gosh, are you kidding me? And it equals 0, doesn't it? Well, here's the deal. Even though they gave me a power of 3, I'm still going to try to break it down and make it a multiplication problem, just like we did problem number 4. Because if I can take this equation and break it down to at least a couple of parentheses, then it's easy to solve. But remember, before you factor, it must be equal to what? It must be equal to 0. And again, some of you are like, why do we do that again? Remember what I said in the very beginning of this video. If A times B equals 0, then A's got to be equal to 0 or the B has to be equal to 0. That's why we must have it equal to 0. Because when you multiply 2, 3, 5, 10 numbers together, a million numbers together, and they equal 0, one of those numbers has to be a 0. Got it? Okay, so first thing we got to do is what? Factor. So first on our list is to factor. And we can do that because it is equal to 0. No problem. So, what's my first step of factoring? Good, to try to reduce it. So is there anything I can reduce this by? Yes, I can take an x out. So I have 8x squared plus 13x and then plus 5, right? Am I done with factoring? You're right, we're not, because this second degree equation this second degree polynomial could probably factor still. So I'm going to hold on to this guy. I'm not going to forget about him, but I don't want to deal with him right now. I want to see if I can factor this second degree polynomial. And we know how to do that because we did it over here. So remember, we're using the same process that we learned in a previous lecture. So, yep, take the first number, which is 8, multiply by the last one, which is 5, which gives you, 40. Boy, that might help, right? Might help if I could multiply correctly. Okay, 40. And now I need to find all the combinations that multiply to 40, and that's a positive 40. And I'm hoping one of those combinations, that's a positive. I'm hoping one of those combinations will actually add up to what in this case? Yeah, I'm hoping it add up to a positive 13, right? Let's see. Oh, I think I just found it. Doesn't a positive 5 times a positive 8 give me a positive 40? And doesn't that add to a positive 13? Then we just found the combination. So now we're going to write 8x squared plus 5x plus the 8x plus 5, right? And then we're going to pair them up or group them, correct? Okay, so what can you pull out of the first pair? Yeah, just an x. So when you do that, you have 8x plus 5. Out of the second pair, good, you're going to take out a positive something because that first term is positive. And what goes into an 8 and a 5? Well, yeah, just a 1. So great. So I factor out just a 1. So be it. And what remains is 8x plus 5. And now we can see that x plus 1 had been distributed to the 8x plus 5. Correct? Oh, yes, and remember, see that little x we pulled out in the beginning? See this guy? That's part of the factoring, wasn't it? Okay, so we factored the original problem, didn't we? And now that means this original problem, which is now factored, this problem must equal 0. Now check this out. In this case, I have 3 items multiplied together that equal 0. Well, like we said before, even if you multiply 10 numbers together and they equal 0, one of them's got to be 0. So, this first number, or first variable, or, if I put that in parentheses, first parenthesis must be 0. The second parenthesis could be the 0, or the third parenthesis could be the 0, right? Well, this guy's already solved, isn't it? Yay! This one? Good, easy to solve. Just move the 1 over. So I have 2 answers. Oh, wait. But I got a third answer here, don't I? After I move that 5 over, after I divide by 8, I actually have a third answer, don't I? You're like, how would I have known in the beginning I was going to get 3 answers? Notice the degree of the polynomial is 3. That means you're going to get 3 answers for x. Didn't we get 3 answers for x? We sure did. Now, some of you may be asking a question, and you may be going, are they always going to equal 0? Well, what do you think? Yeah, they're not going to be that nice to you. These will not always equal 0. And you're like, well, what do I do then? Glad you asked. Stay tuned for a couple more examples. Okay, as promised, number 6, is it equal to 0? No, it's not. So what do you think you're going to have to do? Yes, because the degree of this polynomial is not 1. Hear what I'm saying? Because the degree of the polynomial is not a 1, you need to make it equal to 0. Because it's not a 1, you're going to have to factor it to solve it. So I'll say that again because you need to write this down. Because the degree of the polynomial is not a 1, you're going to have to factor it to solve it. But to factor it correctly and solve it correctly, it must be equal to 0. Got it? Okay, so pause the video, rewind it, hear me again, write it down, and then let's move on. Okay, you're done. Let's move on. So, first things first, I got to make it equal to 0. Good, so move the 20r to the other side. And when you move it to the other side, please make certain that you put it in descending order, right? So I'm going to have 2r to the third plus 6r squared minus 20r. And now it equals 0, doesn't it? Okay, and so then now that it equals 0, what are we going to have to do? Yes, because it's not a first degree equation, I'm going to have to factor it. So, first things first, let's factor. And we are going to factor 2r to the third plus 6r squared minus 20r. What do you check for first? Good. Is there anything that I can reduce this by? I can take that r out. Oh, I can take out a 2r, can't I? Because they can all divide by 2, can't they? As well as an r. So take out the 2r. So what remains when you divide everything by 2r? Yeah, the first one you get an r squared. The second one, a 3r. And the last one, a minus 10. Now we factored something that looked like that already, didn't we? Except it didn't have r's, it had x's, right? Okay, so if you need to, go back to, I think it was example number 2, and go look how we factored that. But this is going to finish factoring into r plus 5, the quantity. Remember, when I say the word quantity, that means parentheses. So the quantity of r plus 5 times the quantity of r minus 2. Cool? Okay, which means the equation we're solving is 2r times the quantity of r plus 5 times the quantity of r minus 2 equaling 0. Cool? Okay, now what are you going to do? You're going to set each one of these equal to 0, right? Each one of these items that are multiplied, right? And some of you might want to put the 2r in parentheses to help you recognize that that's going to get its own little parenthesis, so to speak. That's its own little item to be multiplied. Okay, so here, right, divide by 2, you get 0. So there's one answer. That's right, minus 5, so you get r equals negative 5. That's a second answer. And one more answer, right? How did you know that you were supposed to have 3 answers again? Yeah, because the degree of the polynomial was a 3, which told me I was supposed to end up with 3 answers, and I certainly did. Cool? Okay, let's look at problem 7. You're like, it's already factored. Yes, we can just... And I'm stopping you there. Why? Because is it equal to 0? Nope. Remember, the beginning of the video, the statement said if a times b equals 0, then one of those numbers has got to be a 0. If you have two numbers, or parentheses in this case, that multiply to 24, you know, one of those parentheses could be a 4. Another one could be a 6. One could be a negative 4. One could be a negative 6. One could be a 2. One could be a 12, a negative 2, a negative 12. Oh my gosh, wait, one could be a 48 and one could be a 1/2. There's too many possibilities of what two numbers could be if they multiply to 24. But if they multiply to equal 0, then I know one of them is definitely a 0. There's no ifs, ands, or buts about that. So I know this looks factored, but because it does not equal 0, you're going to have to distribute these, because that 24 has got to move over. Just like in problem 6, we move the 20r over. Well, in this particular problem, though it may look factored, not done, not correctly factored, not fully factored, because the 24 is on this side. So again, pause the video, rewind this little part to make certain you understand what we have to do. This is not considered factored because it's not equal to 0. So you're going to have to, whether you like it or not, distribute this. So we end up with x squared plus 4x minus x minus 4 equaling 24. I'm going to collect the like terms, right? And then, whoops, that's a positive 24. And then I need to bring the 24 over, don't I? So I have to subtract the 24 from both sides, and when I do, I end up with a minus 28 at the end. And now it equals 0. And because it equals 0, and this is a second degree equation, I've got a factor. So I have got to factor the x squared plus 3x minus 28. With me? Okay, so make sure you understand why we had to distribute here. Because now that it equals 0, now this problem is just like the last 6 problems we've done. So 1 times negative 28, right? Find all the combinations that multiply to a negative 28. And I'm hoping one of them is going to actually add up to a positive 3. And I think I just... Nope, I didn't find it. Ah, now I found it. Negative 4 times 7 multiplies to a negative 28, right? But it also adds to a positive 3, doesn't it? Okay, which means I'm going to have x squared minus 4x plus 7x minus 28. We pair them up, right? What do we take out of the first pair? An x, good. So I have x times the quantity of x minus 4. What do we take out of the second pair? Good, a positive, and it's a 7. And what remains is x minus 4. And so now we can see that the x plus 7 had been distributed to the x minus 4. Cool? Which means the real problem, right, that we are factoring is x plus 7, the quantity, times the quantity of x minus 4 equaling 0. Set each one of these equal to 0, and I end up with x equaling a negative 7. And I end up with x equaling a positive 4. And if you take either one of these answers, well, you have to check them both. But when you take these answers, you have to plug it back to the original problem. But you only take one of them at a time and plug it in to make sure it works. And after you check that one, then you take the second answer, plug it in, and make sure it works. Cool? Okay. Hang in there, because I actually have some applications for us.